Hello, this is Group 2. This is our presentation for the simulation of a warehouse distribution system. I'm joined by Emiliano Greco, Michael Pascusa, and Margarita Giron. I'm Gerson Cartagena, and this is our simulation. So the objective of our simulation was to model an efficient system of warehouse distribution that successfully routes arriving shipments to a processing server that will then route the pallets to a corresponding storage aisle. So in here, we have our simulation that we have been working on for the past few weeks. We would like to present our clarifying assumptions, which is that our workers follow a set path. They don't take any shortcuts. So all the paths that you see here are the paths that the workers will use to move the pallets in the aisles. We also have the assumption that the behavior in the bins is the same as the behavior between each bin. And we also assume that there's only human workers in the warehouse. So shipments are generated based on a rate table created from the historical data. This rate table serves as a distribution. With the data that Simio provided us, we were able to make an actual distribution with Excel. So what we did was we created a rate table. And after we put that rate table into Simio, we implemented it into our source. And that is what's determining the arrival of shipments and the distribution of the shipments. After this, the shipments are then routed to a dock by a transfer node according to a discrete cumulative distribution where they are loaded by a worker and placed in a holding area. And then the pallets are picked up by workers and assigned to a random aisle. So here's the histogram, the graph for our shipments per hour. This all comes from the rate table. And after the shipments are generated, they're distributed, dock-based distribution. So after we shipments per hour, we generate a distribution of docks based on a discrete cumulative distribution function. And we did that distribution Simio provided to us. We were able to pull out the row labels, which is the number of the aisles, and the case number that actually went into the aisle. And with that information, we were able to create a distribution, which we then implemented into our simulation using this transfer node right here. And we created an add-on process in which we use a random discrete distribution. And in that way, the shipments go to random pallets according to our data. We also use the hypothesis test, use MATLAB to test our hypothesis. And we use an exponential function, and we were able to reject the null hypothesis, which means this was the right distribution to use. It was the best fit for our dock distribution. We tried a normal distribution, but it was unable to reject that null hypothesis. So after the shipments arrive to the docks, they are processed. They are processed based on a triangular distribution that was provided by Simio, and we inputted that information. So once the shipments arrive to the docks, they are processed by our workers, and this processing time is based on a triangular distribution that was provided by Simio. And to input that in our simulation, we went to each and every dock in our Simio file, used separators in order to process these pallets, and we inputted the random triangular distribution, which is the time that it takes to process, and we created a variable called number of pallets, and that's the entity that's being processed at the docks. So after the shipments are processed, they are turned into pallets, and we obviously need a certain amount of pallets that are generated so that it could be then transferred to the aisles. And the pallets at the docks are generated based on a CDF created from historical data. And we use the number of bins and frequency of each bin to generate our distribution. And here we have our distribution. We made a list of bin and the frequency. And then we were able to generate our PDF and CDF along with our histogram of the number of pallets. And to input that number of pallets, the number of pallets that are actually being made, we went to the member output of each dock and created an add-on process. So after we were able to generate the distribution for the pallets, we input it in our Simio by using the output at the source, We created an add-on process where we rounded up our random continuous distribution and use our model entity, our pallets, to create the number of pallets, the exact number of pallets that are being distributed within the aisles. We also tested our hypothesis. We used an exponential distribution for our pallets, and we were able to reject the null hypothesis, which validates our model. But with the normal distribution, we were unable to reject the null hypothesis.
Each pallet is distributed to a random aisle, utilizing the label of each row and the case number that arrived at each row or aisle. We created a CDF, which you can see here in our data analysis, which we then implemented into the simulation at the pickup station. The process that we created right here utilizes the CDF to route each of the pallets to one of the aisles. For the pallet distribution to the aisles, we ran both an exponential distribution and the normal distribution, and in both cases we were unable to reject the null hypothesis.
So other than the distributions, we have processes within our warehouse and our simulation. First of all, in all of our processes, we use this decide add-on process, in which we stated that the only entities that could move away from each process are the pallets and the shipments, because we don't want any workers get entangled with our pallets and shipments. We also added set notes at the output of every dock so that the pallets can go straight to their pickup stations and not be interrupted by anything on the way. We also added set notes on our transfer notes in order to assign an exact dock number and an exact aisle number. So we created tables in our data with the nodes where the inputs for our aisles are, and the nodes where the input of our docks are, and used it in order to assign that specific dock and aisle through these set node processes. When it comes to our workers, we have 4 warehouse workers and 4 receivers. We created schedules for each of our workers. In this project, we had 2 receivers in one shift and 2 receivers in another shift. And each receiver has his own, the 2 morning workers has his own schedule, and the 2 afternoon workers have their own schedules. And when it came to the pallet operators, the warehouse workers, we just had 1 worker with a population of 4, and we created 1 work schedule, in which it covered the whole day of work.
We also ran 150 experiments over a 30-day period, which was pretty useful because in the reports that were generated, we can see what the average cost tends to be over all of those that were run. Back in the model, we try to make it look as realistic as possible. So in the 3D view, you can see that we added where all the shipments come in, which is the source, and then at all the docks we have what appears to be like a working table where they process all the shipments, turn them into pallets, and then in the aisles we included racks to show what it would look like where all the pallets are going to be stored. We also included the shipment, what's going to be arriving in trucks, the pallets, which is just a stack of pallets, and we have all the workers.
So now we're running the model in order to show how our simulation is working and how we get the results. So we press stop, we fast forward until the workday begins. As you can see, our shipment arrives. And it's processed by a worker. Another shipment arrived. And it's being processed by the workers. And after it's being processed, the pallets go to the pickup station, and we have workers picking up the pallets and putting them in their respective aisles. So you can see they are following a path. They don't take any shortcuts, and they're in charge of distributing the shipments in the aisles. We can also do a 3D view to get a better look of how our warehouse is operating. So now, in order to get the final results of our simulation, we will run a simulation for 20 days, which is, we would be from February 5th to February 25th. And after our simulation is complete, we are able to pull out the results. And we have important information like the cost. So the total cost of all of our workers comes up to be around $314,000. And other than the cost, we could also look at the utilization of our workers. So we just press all of our workers. We can see how are they utilized by their schedule. We can see the distance traveled, the average units they allocate every time they pick up a pallet, and all those sorts of stuff.
So now that you've seen all of that, this concludes our simulation. It's safe to say that it's been a great learning experience. So thank you for all the help throughout the semester, and we hope you like what we've done.